Okay, so for questions 1 and 2, we just want to simplify each expression. That just means we want to start off by factoring everywhere possible. So for the numerator, we're going to use our asterisks. So in my asterisks, I need 1 at 10 and 2, negative 15 in the bottom middle, and positive 54 in the top middle. So my two numbers that multiply to give me 54 and add to give me negative 15, negative 6, and negative 9. Look at your two fractions. Can you reduce either one? No. So your numerator turns into n minus 6 and n minus 9. For the denominator, you can't use an asterisk. You must take out the greatest common factor. So looking at 4n and 36, they're both divisible by 4. If I factor a 4 out, that means you're taking both terms and dividing them by 4. Well, 4n divided by 4 is 1n, or just n. And negative 36 divided by 4 is negative 9. On the top. So now I have two factors that match. I have an n minus 9 on the top, and I have an n minus 9 on the bottom, which means I can cancel those out. That leaves me with an answer of n minus 6 divided by 4. And that is my final answer. I can't simplify anything else. I can't reduce anything else. That is your final answer. Question number 2 is really similar, except they flipped it. Greatest common factor is now on the top, asterisk is on the bottom. So for my greatest common factor of the top, looking at those two terms, 9m squared minus 36m, they have 9m in common. So if I divide both terms by 9m squared divided by 9m, first term divided by 9m is just m. And then negative 36m divided by 9m, the m's will cancel, so just negative 36 divided by 9, negative 4. Then for our denominator, we're going to use our asterisks. So we have 1 at 10 and 2, 6 in the bottom middle, and negative 40 in the top middle. So two numbers that multiply to give me negative 40 and add to give me 6. Negative 4 and positive 10. That means my factors, m minus 4 and m plus 10. Perfect. So our m minus 4s on top and on bottom are going to cancel. And that leaves us with 9m on the top and m plus 10 on the bottom. You cannot cancel those m's out. The top one's involved in multiplication, the bottom one's being added to. So anytime there's addition or subtraction in front of it or behind it, you can't cancel it unless it's in parentheses. So those are the first two problems, asterisk and greatest common factor on both of them. Questions on these two? All right. Moving to question number 3. So for question number 3, we have a multiplication problem. To do this, we need to factor. So for the numerator of the first fraction, k squared minus 13k plus 36, we're going to put that into our asterisks. When you put that into your asterisk, you need two numbers that multiply to give you 36 and add to give you negative 13. Negative 9 and negative 4. For the denominator, you have two terms, but they share a greatest common factor. So the denominator has a k in common. If I factor a k out of k squared plus 8k, I have k plus 8 left. So that's my first fraction. Nothing cancels within it, but that's okay. We're going to keep going to our second fraction. Our second fraction is 2 asterisk problems. So I'm going to take the top, put it in my asterisks, 2 numbers that multiply to give me negative 40, but add to give me 3. Negative 5 and positive 8. Those multiply to give me negative 40 and add to give me 3. For the denominator, k squared minus 9k plus 20, 2 numbers that multiply to give you 20, but add to give you negative 9. Negative 4 and negative 5. So my denominator has 2 factors, k minus 4, k minus 5. Now, do we have anything that can cancel?
Yes, k minus 4, k minus 4, k plus 8, k plus 8, k minus 5, k minus 5.
So we have lots of things that are able to cancel. Remember, you can only cancel if one's on top and one's on bottom. It doesn't matter which fraction they're in because they're being multiplied together. So the k minus 4s, the k minus 5s, and the k plus 8s all cancel. That leaves me with k minus 9 on the top. Yep. So k minus 9 on the top and k on the bottom. So these 2 terms right here, which is answer letter A. Questions on this one? A lot of factoring. On these? So questions 4 and 5. 4 is really similar to question 3. Question number 5 moves into division. We'll get there in just a second. So for question number 4, looking at the numerator. When I look at the numerator, it's a quadratic, which means I'm more than likely going to use my asterisks. So b squared plus 8b minus 20. Personal opinion, I can't stand b's in my problem because my b's look like 6s. So I'm changing my b's to x's. If you do that on your test, that is perfectly fine with me. I would rather you change them all to x's than to write a 6 instead of a b, or vice versa. So for the numerator, I'm putting that in my asterisks, 2 numbers that multiply to give me negative 20 and add to give me 8 would be x plus 10 and x minus 2. So negative 2 times positive 10 is negative 20. When I add them together, I get positive 8. So asterisks. For the denominator, I have b squared minus 100.
Would it be x minus 10?
So it's a difference of squares, perfect square minus perfect square. 2 sets of parentheses, 1 plus sign, 1 minus sign, and then you are indeed square rooting both terms. So the square root of b squared is b, because b times b is b squared. So b goes first in both your parentheses, and then 10 times 10 is 100, so 10s go second in both your parentheses. If you were to box these 2 sets of parentheses and put them back together, you would end up with b squared minus 100. For the tricky part for question, or for the second fraction, what do you notice about the numerator of the second fraction?
It's 2b squared minus 1.
Say that again.
Yeah.
Yeah, so they're all even. Instantly I know, since I have 2, 22, and 20, I have a greatest common factor, and I must bring it out. If not, it will get lost in your asterisks. Actually, it'll get canceled out in your asterisks. So I want to factor out a 2 before I use my asterisks. If I factor out a 2, that leaves me with b squared minus 11b plus 10. This is what you're going to use in your asterisks. I promise you, on your test, on question number 4, there will be one part where you have to take out the greatest common factor. Just like this. So we're taking out the 2, and then we're taking what's left and putting that into our asterisks. If I put that into my asterisk, I'm looking for two numbers that multiply to give me 10, but add to give me negative 11. Yep, negative 10 and negative 1. And then for my denominator, 12b minus 12, nothing's squared, so you can't use a difference of squares. All you can do with the denominator is the greatest common factor. They have 12 in common. If I factor 12 out of 12b, or x, leaves you with x. And then don't forget the second term. I have minus 12 divided by 12. Well, negative 12 divided by 12 is negative 1. You must have that minus 1 in there. Now that everything's factored, I can go through and cancel
X plus 10, X minus 10.
the x plus 10s, the x minus 10s,
X minus 1.
the x minus 1s. Anything else? That 2's for when we factored out the greatest common factor. What about this right here?
Reduce it.
Reduce it to what? 1/6. So left on the top, I have a 1, and I have x minus 2. Well, 1 times x minus 2 is just x minus 2. For my denominator, you have that 6 left in the bottom. In the past, the biggest mistake for this problem has been not taking that greatest common factor out. You'll get a really similar answer, except you'll have 12 on the bottom.
And I did.
Again, we're going for full credit, not just partial credit. So I want as many points as we can. Yep, every point counts.
The next one we can just flip it, right? Change the multiplication.
Yes, so question number 5 is division. To simplify division problem, we keep, change, flip. Keep your first fraction the same. Change your sign to multiplication. Keep, change, flip. Flip your second fraction. So we're keeping the first fraction the same, 6p minus 54 over 8p plus 72. Change your sign to multiplication, and then flip your second fraction. So the p plus 9 goes to the top, and the p squared minus 11p plus 18 goes to the bottom.
And we don't change none of that, right?
We're going to factor it in just a minute.
I meant like,
What do you mean?
we don't like make them change the negative and positive.
Because it's division. So now this question is exactly like question number 4. You're going to factor as much as you can. Looking at the numerator, 6p minus 54, you have a greatest common factor. Yep, you're going to factor out a 6. When I factor out a 6, 6p divided by 6 is just p. And negative 54 divided by 6 is negative 9. So the numerator factors into 6 times p minus 9. For the denominator, 8p plus 72, again, greatest common factor, this time is 8. So we're going to factor an 8 out of 8p, which leaves you with p. We're going to factor an 8 out of 72. Well, 8 times 9 is 72. This time it's a positive 9. Don't let that negative 9 on the top confuse you. Can't cancel those. They're different signs. For our second fraction, the numerator does not factor. The numerator stays p plus 9. Just bring it on over. For the denominator, you have a quadratic, which just means you have an asterisk problem. Perfect. -2 and -9. So p minus 2 and p minus 9. I want to go through and cancel anything that's allowed. What can I cancel?
P minus 9, P plus 5.
Yes.
P minus 9 and P plus 9.
Yep, the p plus 9s and the p minus 9s. There is something else you can do. Reduce the 6 and the 8. They're both divisible by 2. 6 divided by 2 is 3. 8 divided by 2 is 4. So when I look at this, what is left in the numerator for my final answer? 3. And then in my denominator, I have the 4 left, and then the p minus 2 in parentheses. You can leave your answer just like that. There's no need to distribute that 4 in. You can't cancel anything. That is your final answer. Questions on the front page? On the back page, we are simplifying expressions with addition and subtraction. To add and subtract fractions, you must have a common denominator. To get a common denominator, I first of all need to factor where possible. Notice right here you have a difference of squares. This actually factors into t minus 3 and t plus 3. So my least common denominator happens to be t plus 3 and t minus 3. Both of my denominators in this problem have either one or both of those parts. So when I look at this, the first fraction is missing the t plus 3. That means I have to multiply the top and the bottom by t plus 3. When I take and multiply the top by t plus 3, the 5 just gets distributed, which gives me 5 times t, which is 5t, plus 3 times 5, which is 15. And that's still over t plus 3, t minus 3. So there's my first fraction with my new denominator. Do I need to make any changes on the second fraction? No, it already has the least common denominator. It just wasn't factored in the original. So the second fraction doesn't change at this point. Now when I look at these two fractions, do they have a common denominator?
Yes, they do.
Yes, they do. What are you going to do with these?
Nothing.
How do I add them together?
You add the like terms, so you have the 15 and the 4.
So I'm adding like terms just on the top, in this case just the 15 and the 4. So 5t stays the same. 15 plus 4 gives you 19. So 5t plus 19. Do I change anything in the denominator?
No.
No, I'm going to leave it as t plus 3 and t minus 3. Which gives me answer letter A. Remember that these signs right here, order doesn't matter as long as you have them both. So I know mine's written backwards in the denominator, but that's okay. You have the same two sets of parentheses. Doesn't matter what order you multiply something. Good. Questions on that one? Questions 7 and 8 are similar. 7's a little bit shorter because you don't have to factor anything. Actually, neither one of these you have to factor anything.
You just make the denominator the same.
You do need to make the denominator the same. So looking at just my numbers, I have a 6 and I have a 2. What should you do?
Can I multiply the 6x by the 2y squared?
You could.
Would it be harder?
So, least common denominator. I need the smallest number that's divisible by 6 and 2. 6. 6 is divisible by 6 and 6 is divisible by 2. So my least common denominator is going to be 6. And then looking at my variables, one of them has an x in it, so it has to go in my least common denominator. The other one has y squared in it. So my least common denominator is going to be 6xy squared. Now all you have to do is multiply by the parts that are missing for the current denominator. So looking at this denominator here, I have the 6 and I have the x. Just the y squared is missing. So I'm going to multiply top and bottom by just y squared. Well, y squared times 4 is just 4y squared. For the denominator, 6x times y squared is 6xy squared. Plus your second fraction. For my second fraction, what do I need to multiply 2 by to get 6? 3. What do I need to multiply my y squared by to get xy squared? X. So the second fraction is getting multiplied by 3x on top and 3x on bottom. So for my numerator, 3x times 5x, well, 3 times 5 is 15. And x times x is x squared. My denominator, 3 times 2 is 6. X times y squared is xy squared. Now do we have a common denominator?
Mm-hmm.
Perfect. What are we going to do to add these together? We got to do something. Can't have two fractions. We're looking to get one.
6 on one side, 6 on the other. The side divided? No.
You don't have an equal sign.
Why?
So, problems addition. Can I add my like terms on the top?
No.
Do I have like terms on the top? No. I'm going to just rewrite the top in one fraction. So I'm just pulling that plus sign up. So 4y squared plus 15x squared. They're not like terms. You can't add them together, but you can put them beside each other with addition.
Okay.
And then what's your denominator?
6xy squared.
6xy squared.
Circle it.
Circle it, you are done. Now, depending on how you do this on your test, you might have to reduce. What I mean by reduce is, if I look at these three numbers, are they all divisible by something? Can I reduce them all? No. On your test, depending on how you do it again, you might have to reduce them. Just be warned. So if they were all, if that 15 was a 16, they would all be divisible by 2, and I would have to reduce it. In this case, they're not, so that is your final answer. Question number 8. Again, gotta get a common denominator to subtract. For this one, my least common denominator. Whoops. I have essentially two sets of parentheses down here. My least common denominator's got to have them both. So it has to have the x plus 4 and the x plus 3. So looking at my first fraction, what does my first fraction have to get multiplied by?
X plus 3.
The x plus 3. So I'm multiplying x plus, top and bottom by x plus 3. So the x plus 3 gets multiplied by the 7. 7 times x is 7x. And 7 times 3 is 21. My denominator is just going to be the x plus 3 and the x plus 4. So there's my first fraction. I want you to do yourself a favor. Get rid of this minus sign in the middle. Change it to plus sign, and then you have to change all the signs at the top of the next one. In this case, just the 4x gets changed to a negative 4x. Majority of the time, my students who forget to do that get the problem wrong. Or some part of the problem wrong because they didn't do that. They forget about that minus sign being there. So then we now need to go ahead and figure out what we have to multiply the second fraction by. What's missing out of the denominator? X plus 4. So I'm going to multiply top and bottom by x plus 4. So now I have negative 4x times x, which is negative 4x squared, and negative 4x times 4. Negative 16, don't forget your x. Your denominator is the x plus 3, x plus 4.
Now you have a couple like terms.
Yes, so now I have a common denominator, so I can add my tops together. Anytime I have like terms, I need to combine them. So I always start with the highest exponent. Highest exponent is the x squared, so negative 4x squared is the first term that I'm going to write. Then I have like terms with my 7x and my negative 16x. Minus 9x. And then my plus 21 comes down. Does my denominator change?
No, you
Rewrite it. X plus 3, x plus 4.
Now you're done?
Final answer.
I'm over here trying to put an asterisk.
So you can try to put that in your asterisk. It will not work. And on your test, it will not work.
So if you had x plus 4 and then x plus 3, does it matter?
That's fine.
Hi, Tam Tam.
Questions on these two?
No.
Oh, good, you're the one I need. Perfect timing. I struggled with that one too. I don't even have the answer key.
So question number 9. Question number 9, similar to what we did yesterday. Now we have an equal sign. Equal signs make our lives easier because we can cancel things out.
Right.
So looking for our common denominator, first thing I notice is one of them is a quadratic and I should probably factor it. So I'm going to take that first denominator and I'm going to factor it. X squared minus x minus 20. So put that into your asterisks. Two numbers that multiply to give me negative 20 but add to give me negative 1. Negative 5 and positive 4. So now, I'm just going to scribble that out. That denominator factored into x minus 5, x plus 4. What do you notice about the other two denominators? They're one of each. X plus 4, x minus 5. So we're going to have to multiply every single denominator by the common denominator. What is our common denominator?
X minus 5, X plus.
Yep. X minus 5, x plus 4. When I do that, what happens with the first fraction?
It's going to cancel.
It's going to cancel. What's going to cancel?
You're looking left with 5 because your X.
This cancels. Oops, those had opposite
Yep,
lines.
your X minus 5 cancels X minus 5 and your X plus 4.
Yep.
cancels X plus 4.
Both terms in your denominator cancel and you're left with 5. Bring down your minus sign. Or better yet, we should move it for the next part. So change that minus to a positive, move that negative up with your 1. And then I'm going to multiply the second term by x minus 5 and x plus 4. Does something cancel?
X minus 5.
The x minus 5 should cancel. If you're doing this correctly, the denominator should cancel from all of them. So if I multiply by x minus 5 and it's being divided by x minus 5, those simplify, cancel out. So really, all I have for this part is the negative 1 times the x plus 4. Well, negative 1 times x is negative x, and negative 1 times 4 is negative 4. For our last term, so bring down your equal sign. Now we have 1 over x plus 4, and we're multiplying by x plus 4, x minus 5. I should cancel my x plus 4s out. One's on top, one's on bottom. So that cancels with that, and then I just have 1 times x minus 5, so 1 times x is x. 1 times negative 5 is negative 5. Now you have just a regular algebra problem. So you want to combine like terms.
So the 5 and the negative 4.
The 5 and the negative 4, sure. 5 minus 4 is 1, so 1 minus x equals x minus 5. I would add x to both sides to cancel this one out. So 1 equals 2x minus 5. Add 5 to both sides.
6 equals 2x.
So 6 equals 2x. Beside it, divide it. Divide both sides by 2 to get your final answer of
X is 3.
x equals 3, which is letter C.
Okay, so y'all, where we get the 2 from?
X plus
The x, we added x to both sides.
Okay.
Kind of a tricky question. At least it's multiple choice.
I like how this one's so cool.
Alright, question number 10. Question number 10, first thing you need to decide, what is your least common denominator? 2r. I'm going to multiply every single term by 2r. 2r and 2r. So all these are being multiplied by 2r. If this is correct, something should cancel or reduce in every single part. So for my first fraction, what's going to cancel? The 2's cancel. What are you left with? 5r. Perfect. Plus, what cancels for your second fraction? So I can only cancel something on the top with something on the bottom. The r cancels with this r. That leaves me with, be careful, the r plus 2 that was already there gets multiplied by the 2 that's left on the top. So 2 times r is 2r, and 2 times 2 gives me 4. So plus 4. So 2 times r is 2r, 2 times 2 gives me that plus 4. So 2r plus 4.
So I can go ahead and cancel 2r, right? And I'm
Yes.
left with r minus 7.
Perfect. So on the right side, you're going to cancel your 2r with your 2r. And you're left with the r minus 7. Again, you're back to an algebra problem. Combine like terms. I would
Plus 2r.
Yep, I would go ahead and combine these two terms here to get 7r. Then I would subtract r from both sides, so 7r minus r is 6r. Be careful, because now on the right side you have a minus 7. You've got to bring that minus sign down with your 7. You lost it?
Yes. Oh, I'm doing a different way.
That's fine. Subtract 4 from both sides. 6r equals negative 11. Beside it, divide it. You get r equals negative 11 over 6. I would recommend you leave your answer just like that.
Okay, I got it. But mine is 6 over 11.
Here's backwards.
Yeah, I have to go backwards.
You should be dividing by 6.
Okay. 11, I did. 11, negative
No,
6.
you're 11 over 6.
Girl, what if my brain is dead?
You're good.
11 over 6, okay.
Negative 11.
Okay.
Alright, questions 11 and 12 are the problems like the ones we did yesterday. So we have people either working together or working individually, and we're trying to find a missing time. So Adam can mop a warehouse in 8 hours. Adam's working alone, doing it in 8 hours. Wilbur can mop the same warehouse in 12 hours. Again, Wilbur's working alone. So we have two individuals, independent times. If they work together, how long would it take them? So for this, remember, we want our together time. Do we know the together time? No, so I'm going to put a T for together. Together time over individual. Well, Adam can do it in 8 hours, so I'm going to put Adam first. So T over 8, as soon as I can reconnect. Plus, let's talk about Wilbur. We don't know how long it takes Wilbur and Adam to do it together, so we're going to put T again. This time, Wilbur can do it in 12 hours. And we want them to equal one whole job. We want them to do it together to get one whole job done. What is your least common denominator? So I need a number that's divisible by 12 and 8. You're thinking least common multiples. I can't take 2 and divide it by 8. I want the number that you tell me to be divisible by 8. I can divide it by 8, and I can divide it by 12. So it's got to be bigger than 8, and it's got to be bigger than 12. First thing I would check, can I take 12 and divide it by 8? No. Think of multiples of 12. So I can't take 12 and divide it by 8. You're going wrong direction. It's got to be bigger than 12.
32.
24. Is 24 divisible by 8?
Yes, and 12.
Is 24 divisible by 12?
Yep.
Yes. So the common denominator would have to be 24, or you can make a bigger one. When in doubt, you can multiply 12 and 8 together. Your numbers will just be bigger all the way through until you get to the end. You'll get the same answer. So if you forget, it's fine. Multiply them together, and then multiply every single term by that. You'll have bigger numbers in the process, but that's okay. Just be careful with it. So I would, since we know it's 24, multiply every single term by 24. What that does is creates a problem for us to reduce. If I take 24 and I divide it by 8, you get 3. So 3's left, and so is the t, so 3t plus. If I take 24 and I divide it by 12, what do you get? 2, so you have 2t. Equals 1 times 24. Don't forget to multiply that 1 by the 24. So 3t plus 2t equals 24. Perfect. Now what, Wanda?
Like terms?
Like terms. So 3t plus 2t is 5t. Perfect. So now I have...
24.
Yes.
Okay. So
5t equals 24.
So
Divide both sides by 5. Perfect. So t equals 4.8. T represented their together time, right? How would we label this?
Yay.
Hours.
4 hours and 8.
Leave your answer as 4.8 hours. I'm not going to make you convert that 0.8 to minutes. Also, I know the question says that you need to write a complete sentence that explains your answer in relation to the question. I just want you to label it hours. So if Adam and Wilbur work together, they should be able to complete the whole job in 4.8 hours. Remember, if they're working together, their together time should be less than both of their individuals. If Adam can do it in 8 and together it takes them 10, there's a problem. Too much talking, yes.
The swan is not there to keep us in track.
That's right. Nobody's keeping them in line.
I'm trying to do the next one.
All right, so question number 12 gives you different information. So question 12 starts off with working together. Jessica and Jill can build a new deck in 9 hours. That is their together time.
Yeah, so
That is
3 and
the
9.
tops of both of your fractions.
Oh, that's the only thing was I had it backwards. My 9 going on top and my 2 going
Together time always goes on top.
Okay. Yep, exactly.
Individuals go on bottom. We don't know both individuals. We know that it takes Jill 21 hours, but we don't know how long it takes Jessica. So I just put a J for Jessica. You can put any letter you want there. What is your common denominator? I have a 21 and I have a J.
21J.
21J. You're going to multiply every single term by 21J. For my first fraction, 9 times 21J divided by 21, what's going to happen? The 21 cancels with the 21, leaving you with 9 times J, which is 9J. For my second term, 9 times 21J divided by J,
J's canceled.
the J's cancel, leaving you with 9 times 21.
189.
189. No J's in that term. Equals, yes.
21J.
21J. I have like terms, but one's on the left side, one's on the right side, so I need to add and subtract to move it. I would subtract 9J. So 189 equals 12J. Divide both sides by 12. Yep.
Hours.
Yep. So Jessica, working alone, could install this deck in 15.75 hours.
Okay, I'll write it down.
I feel like 12 is easier than 11.
I agree.
You want me to burst your bubble about 12? Oh, wait, 12? Oh, you thought this one was easier than the other one?
Yeah.
Yeah.
Because I could see them canceling.
Right.
Oh, you can't see the others reduced?
Right. See, there we go again with the reduce.
Alright, so question number 13, as promised, there is one long division question on your test. If you use synthetic division, you will get partial credit for it. I'm going to do it with long division. You'll get the same answer to me as if you use synthetic. Using synthetic only loses you 1 point on your test.
What?
If we use
Yes.
the box, will you lose a point?
Because the instructions say using long division.
Mine.
Oh, but we wouldn't lose it on 15 though because 15
Or 16. Or 14.
Right.
14 we would because
No.
oh, you're
Never
right.
would.
So 13 says use long division, 14 says use synthetic division, and 15 gives you a choice. You can use either or.
I'll take that last one.
Is the answer cube wrong for 15?
I hope not.
n squared plus 5m plus 13, 46 over n minus 5.
No, my work is different.
I do the box. Do you do the box?
I did the box, but
Okay.
I'm still learning the box.
I like the box.
I like the box, and it was easy on that one. I switched to
That's
the
why.
sign.
That's where it messed up.
How
0.
did they take 0 minus 5 and then positive 5?
You're adding.
Because you're adding.
You always add.
Over subtract.
You're subtracting, and then on number 14, you
On all of
subtracted.
them, we subtract. We multiply, subtract, multiply, subtract.
Multiply, add. Multiply, add.
No way.
Yes, way.
Because then I would take,
The long division is where you subtract. You don't subtract on synthetic.
50 is 5, 49.
we're saying this should be negative 5. Because if we add, then that would be,
5.
we have to add. I don't know if it helps you, but
All right, so for question 13, again, I'm doing it using long division. If you use synthetic, that's okay. Our process for long division is to divide, then multiply, and then subtract. So when I say divide, we're going to take first term divided by first term. B to the third divided by B is B squared. So that's my division step. When I divide, it just gives me the number that goes up top. Then I'm going to multiply. B squared times B is B to the third.
Wait a minute. Where'd you get 35 from?
Well, it's 34. Thank you.
Okay, you know you can't confuse me.
I'm sorry. I just wrote it down wrong. And then I'm going to take my B squared times negative 10, which is negative 10B squared. This is the part where people tend to screw up. We are subtracting both of these terms.
But they're both negative. Oh, they're positive.
I highly, highly, highly suggest you change that to plus and you change the signs
Now I see.
in the parentheses. And then you just add straight down. B to the third minus B to the third cancels.
Wait. That was supposed to be my head.
And then negative 6b squared plus 10b squared. I have negative 6 plus 10
Negative.
positive 4b squared. We're just adding them together. Your bank account's overdrawn $6. You put $10 in. Now your bank account's 4.
I wrote 66 in my paper.
It's probably because of the b's. Bring down your next term. So I'll bring down your minus 44. B and the cycle begins all over again. I'm going to take first term divided by first term. So 4b squared divided by b. Well, 4 divided by 1 is 4. And b squared divided by b is b. So my top number is 4b. Don't forget your plus sign because we're multiplying by a positive. Then I'm going to take that 4b and I'm going to multiply it by both terms out front. So 4b times b is 4b squared. And 4b times negative 10 is negative 4db. Don't forget, we're getting ready to subtract. If I subtract, I don't want to forget something, so I'm going to distribute that negative to both terms on the inside. So I have a negative 4b squared and a positive 40b.
We have a negative 4b.
Yep, so then I'm going to combine my like terms. Well, negative 4b squared plus 4b squared cancels. Negative 44b plus 40b is negative 4b. Bring down your plus 34, and we're going to repeat. First term divided by first term, negative 4b divided by b is negative 4. I'm going to take that negative 4 and I'm going to multiply. Negative 4 times b is negative 4b. And negative 4 times negative 10 is positive 40. Then we're we're going to distribute that negative so we don't forget about it or do something wrong. So now we have a positive 4b and a negative 40. Add straight down. Negative 4b plus 4b cancels. Positive 34 minus 40 is negative 6. That negative 6 is my remainder. My answer comes from this part right here, so b squared plus 4b minus 4. And then my remainder, since it's negative, I'm going to put minus. 6 goes on top of your fraction, and what you're dividing by, the b minus 10, goes on the bottom. This is my final answer. If you use synthetic division, you will get the same exact answer.
So, but it doesn't say show your work.
Okay.
So what if I just
Have to see you do it using long division to give you full credit. It's only 1 point. Being as generous as I can.
I appreciate
That's
it.
1 point out of 2.
It's 1 point out of 74.
That's the
Or
bigger
that-
picture. That's the bigger
That
picture.
one
That's not my
problem is
problem.
worth 74
No.
points.
No, the
no,
test.
I'm getting ready to say that.
You know how happy we would have been if we got 73 points for that?
Yeah, girl, look. Just go and get my
Had some
test.
excitement in the room then. 5 n squared plus
Yeah, we
5
can
n
walk.
negative 0.7 over n plus 10.
Just to get all fancy there, Andrea.
Oh, I drew a crooked line.
Great.
She's having Josh moments now.
We can't be perfect.
Yes, he take 30 minutes trying to line
He
that
sure
line up
does. He
straight.
really does.
He's a perfectionist.
I would have taken my marker and drawn it on the board and said, all right, let's do this.
Here it is. Yeah.
Exactly.
All right, so for synthetic division, you need all of your coefficients across the top, making sure if I have that first number, it's 5 into the third. The 5 gets brought down. Since it's into the third, I have to go down in descending order. How many n squareds do I have? 55. How many n's do I have? 49. And then my constant comes last, negative, 17.
Show me
I did.
You gotta make your arrow.
straight down.
Yep.
Drop your 5.
Drop your 5. How do I get my magic number that I multiply by?
Do the
Opposite.
So opposite of this, technically you set n plus 10 equal to 0. Solve for n. It is just negative 10. So negative 10 is my magic number. My process for this is to multiply, add, all the way across. I'm going to multiply 5.
So did we jack
But
it?
if you multiply and
Okay.
subtract on the first one, you still get the right answer.
There's no way.
I did because I subtracted.
5 times negative 10 is negative 50. Negative 50 plus 55 is 5.
If you go 55,
5 times negative 10 is negative 50 again. Negative 50 plus 49 is negative 1.
you're working up, bottom up. I was going up.
10.
Negative 1 times negative 10 is positive 10. And then negative 17 plus 10 is negative 7. Make sure you have to write your final answer. How do you get the first term?
You go down 1 from whatever started.
Yep. So the bottom row are my coefficients of my answer. Whatever degree or exponent you originally started with, your answer is 1 less. So the original was n to the third. So for my answer, I'm going to have my first term n squared. So this 5 got brought down, plus 5n minus 1, the bottom last corner, is your remainder. Still write your remainder the same way, minus 7 divided by n plus 10. Circle it, that's your final answer. These should be easy points. I hope.
Got that.
Do we do anything easier than this?
What's easier than this?
So for question 15, again, you want to use synthetic division or long division?
Synthetic.
Aww.
Don't
So synthetic division it is. This one, you must be careful. Somebody tell me why.
Because you have no m squared.
Because you have no m squared. That just means you need to add in a 0. Ooh. So my coefficients are 1 for the m to the third. You have 0 m squareds. You have negative 12 m's and negative 19 as your constant.
Does that,
Bring your 1 down.
Does that 5 have a name for it, like what we put on the side over there?
I call it my magic number.
Magic number.
So our magic number is 5. I don't know if it really has a name. And then we're going to multiply, add, multiply, add. 1 times 5 is 5. 5 plus 0 is 5. 5 times 5 is 25. 25 minus 12, or negative 12 plus 25 is 13. It's because the signs are opposite. 13 times 5 is 65. Negative 19 plus 65 is 46. That 46 is my remainder. The other numbers are my new coefficients. So 1m squared
Yes.
plus 5m plus 13 plus 46 divided by m minus 5. Final answer.
Yes, ma'am.
Do I have to have that plus sign in there?
Yes.
Wait. They got to look at
Should always have a sign because it's being added to your answer. Or subtracted if it's negative.
Oh, but I put it up top.
Alright, moving to the backside question 16. I'll skip the whole page. Oh, mine's stapled backwards.
Yeah, that's it.
Question 16. The problem below is solved incorrectly. Describe the mistake and find the correct answer. My suggestion for these problems is to always take the problem and solve it on your own. Don't look at what they did, or you might do the same thing because it's in your mind. So I'm going to take the original problem. Well, maybe. If I ask you to solve this problem, your first objective would be to isolate the radical. Get that square root by itself. Be very careful. What is happening between the negative 5 and your square root? They are being multiplied. What is the inverse of multiplication? So I'm going to divide both sides by negative 5. That leaves me with the square root of 3r minus 4 equals 4. Positive 4, correct. Now I have my square root by itself. How can I get rid of a square root? Squaring it. So square both sides. When you square a square root, this cancels with this. Leaves me with 3r minus 4 equals, well, 4 squared is 16. Now I want to add 4 to both sides. So 3r equals 20. Beside it, divide it. So my answer is going to be 20 over 3. I again would leave my answer as 20 over 3.
You're going to have to rewrite decimal. You'd be okay with it too.
It would be okay. Unless you typed it in your calculator upside down, and then we would have a problem.
So 6.6. Oh my god, I have to whole thing.
So 6.6 repeating.
Well, it doesn't repeat all the way because you have a 7 at the very
It's
end.
because your calculator rounds it. Your calculator rounded that last number. So describe the mistake shown in the work above. So I notice we both have divided by 3, but they have 229 divided by 3.
They didn't divide that 20. They subtracted the 5.
Perfect. So you're going to tell me that instead of dividing by 5, they added, or dividing by negative 5, they added 5. So step 1 is really where they screwed up. They have a negative 15. They should have a positive 4. So write me a sentence, something about in step 1, the negative 15 should be 4. They should have divided by negative 5 instead of adding 5. Something along those lines. Everybody can have something a little bit different and still be correct.
Oh, right there's where I write my answer.
Yes, you have a line for your answer.
Extreme solutions.
Are we okay on 16? Okay. Moving to 17. Solve the equation. This time we have the square root by itself, so our life gets a little bit easier. So since our square root's by itself on the right side, we can just square both sides. When I square the right side, the squared and the square root cancel. So really I have b squared equals negative 18 plus 11b. This is a quadratic. To solve a quadratic, you need to move everything to one side and use your asterisks. I would not move the b squared because it's going to be negative. I would add 18 and subtract 11b. Add 18, subtract 11b. That gives me 0 on the right side. Make sure when you write your terms on the left, you want to start with the biggest exponent first. So b squared first, minus 11b next, plus 18. You always want them in descending order. Biggest exponent first, and then work your way down. Perfect. Now you're going to use your asterisks. Two numbers that multiply to give you 18, but add to give you negative 11, negative 9, and negative 2. Set them both equal to 0.
So B is 2 and B is 9.
B is 2, and B is 9.
Now check them.
Yes. If you check these just for time's sake, these should both work.
Now when I check them, which problem do I put the
You go all the way back to the original. So go back all the way to the text, like the typed problem. So get rid of all of this. So if I was checking 9, I would have 9 equals the square root of negative 18 plus 11 times 9. Well, 11 times 9 is 99. 99 plus negative 18 is 81. Square root of 81 is 9. Check.
Oh, that's a lot easier than I thought.
Yeah. Same way with 2. If you check 2, it works as well. So these are both answers. Neither one is extraneous. So for question 18, how do you determine if a solution is extraneous?
Because it works.
It works where? When you do what?
When you fill it back into it.
So if you plug it back into the original equation and you get a false statement, it's extraneous.
Oh, so that one is.
So since we plugged 9 in and we got a true statement that 9 equals 9, that one's not extraneous. Same thing happens if you would do 2.
So can I just write extraneous solutions are false?
When you plug them into the original equation. So you get a false statement when you plug it in to the original equation. Can't be anything modified, it has to be the original. So if you plug it into the original equation and get a false statement, then it's extraneous. Something along those lines for question 18. We're going to fly through these last few questions because we just have a few minutes left, but we'll go back over them again tomorrow. So question 19, you have a square root on the right side by itself. If you square both sides, this one's tricky because the left side, you must box the left side. N plus 2 times n plus 2 is a box problem. So n times n is n squared. N times 2 is 2n. 2 times n is 2n. And 2 times 2 is 4. So my box on the left side gives me n squared plus, when I combine like terms, 2n plus 2n is 4n plus 4. And then for my right side, the squared and the square root cancel, leaving you with 31 minus 2n. Trickiest part on this problem is remembering to use your box on the left side. Now you just have a quadratic, you need to move everything to the left side and use your asterisks. So subtract 31, add 2n. So n squared plus 6n minus 27 equals 0. In my asterisks, I need two numbers that multiply to give me 27, but add to give me 6. Yep, n plus 9 and n minus 3. Set them both equal to 0, and you get n equals negative 9, n equals positive 3. Remember, anytime you get two answers, you've got to check for extraneous solutions. This one has an extraneous solution. If I plug in negative 9 right here, negative 9 plus 2 is negative 7, agreed? If I take the square root of any number, am I going to get negative 7? No, negative 9 is extraneous.
So n is 3.
N is 3 is the only one that works.
So since if it's negative 9, we can automatically...
Not automatically. Only if you plug it in and one side that equals your square root is a negative.
Yeah, that's what I was...
So if I would plug that negative 9 in and it was like negative 9 plus 10, it gives me 1. That wouldn't, like, I couldn't just assume that it was extraneous. Alright, so for questions 20, 21, 22, and 23, all we are doing is rewriting them. We are not solving or simplifying anything. So, for 20, our 10v goes in our parentheses. Make sure when you write your exponent, it needs A to be a fraction, but it also needs to be written up in the top right-hand corner. It needs to be really small. It can't be written big like it's multiplication. And then remember, top number goes top, so the 5 goes on top, the 3 goes on bottom. Do not write it like this. Don't write it like that.
Okay.
That is the biggest problem I have with people on these problems. They know what number goes where, they just write it incorrectly. So make sure it's written up in the top right-hand corner, little number, like floating, not beside it. Question 21 is a little bit tricky because there's no number written right here.
It's always a 2, though.
It's always a 2. The smallest root we ever talk about is a square root. So we have 7x in parentheses. My exponent is going to be what? 3 over 2. Perfect. That would be my final answer. Again, there's no simplification needed. All you have to do is rewrite them. For questions 22 and 23, you're doing the opposite. I'm giving you the rational exponent, and you're giving me the radical form. So 4k goes on the inside, 5 goes on the outside, 3 becomes your index. That's your final answer. You could put parentheses here, but they are not necessary. They are necessary for questions 20 and 21. You don't have to have them for 22 and 23. Oh, this one. So this one, we have 5n. My index is 2, my exponent's 1. You could also just write this. The square root of 5n, you don't have to have the 1 or the 2, but you can.
Because you always...
Because the exponent's always 1. The smallest root we ever talk about is the square root, so it's common practice just not to write it.
Okay.
So those should be 4 easy points. Hopefully. Alright, so questions 24 and 25 are the ones we actually have to do. So first thing you're going to do for question 24 is to rewrite it.
Okay, I got it rewritten.
So 64x to the 6 goes underneath my cube root to the 5th power.
Uh-oh.
First thing you need to find.
Oh, I didn't write it in the thingy.
You need to find the cube root of 64. That's a calculator problem.
4 times 64 times 64.
No, you need what number times itself 3 times gives you 64. Or you can do 3 shift caret key 64 equals. 3 shift caret key 64 equals.
4.
Your caret key is the little upside down V on the left. Ooh, yours is different. Oh, yeah, it is. On the left side. Upside down V.
Like this.
3 shift caret key 64.
Yeah.
When you type that in, you should get 4. Because 4 times 4 is 16 times 4 is 64. Now's the tricky part. You can't use your calculator for this part here. I need to take 6 of something and put them into groups of 3. If I take 6 people and put them into groups of 3, how many groups will I have? 2. So this is x squared. I have not done anything with the 5 up top yet. So I'm going to put parentheses around this and the 5's still there. Bringing it down. Bring that 5 down. Then I need to take both terms on the inside to the 5th power. So 4 to the 5th power means 4 times 4 times 4 times 4 times 4. Easiest way to do that is type 4, caret key 5. No shift this time. 1024.
That word. That number.
And then last thing, get your x's together. If I have 2 groups of 5 or 5 groups of 2, how many do I have total? 10. So my exponent is going to be 10. So my final answer would be 24x to the 10th, which is answer letter A. All right, 25, exact same process. We're going to have the 4th root of 81r to the 8th, all to the 5th power. So get your 81 first. 4, shift, caret key 81 to figure out the 4th root of 81. 3. I have 8 of something. I'm putting them into groups of 4. 2. We're dividing our exponent. 8 divided by 4 gives me 2. I've not done anything with this 5 on the outside. 3 to the 5th power means 3 times 3 times 3 times 3 times 3. 3, caret key 5.
I forgot what my
243.
caret key was.
243. Your caret key is on the left side.
Mine said like that, remember?
Yours is the X with the box in the top right hand corner.
Okay.
And then for my R's, I need to take 2 times 5. I have 5 groups of 2, which gives me 10. 243 R to the 10th power. Don't be alarmed on your test tomorrow if you get a large number for the last question. It's okay.